Welcome back to Notes of Curiosity, where, as always, we're exploring ideas that matter. And today we're diving deep, really deep, into a concept that seems deceptively simple at first: mass.
Deceptively simple is right. I mean, we all kind of have a feel for what mass is, right? Like how much stuff is in something.
Yeah. Pick up a rock, it's got more mass than a feather. Easy peasy.
Exactly. But where things get really interesting is when you start to ask, well, what is stuff actually?
Oh yeah, that's a good question.
And that's exactly the question that Jim Baggott tackles in his book Mass.
So we're doing a bit of a book review today for those listening in.
Yes, we're going to be exploring the first 8 chapters just to give you a little taste of the journey Baggott takes us on.
And hopefully spark a little curiosity in our listeners to maybe, explore a little further on their own.
Exactly.
So to kick things off, Baggott takes us all the way back to ancient Greece.
Yes, the birthplace of so many big ideas.
Right. And he asks us to imagine ourselves on a beach, like, with those ancient philosophers.
Just contemplating the nature of reality.
Exactly. And that's where we meet the atomists.
Like Democritus, one of the very first to really think about the world in terms of, well, atoms.
So what was their big idea? What did these early atomists believe?
Well, they believed that everything around us is made up of these tiny, indivisible particles.
Atoms.
Atoms, exactly. And these atoms are constantly moving around in this void, this empty space.
So no air, just atoms and empty space.
Pretty much. And they thought that different combinations of these atoms is what gives us all the different substances that we see. Wood, water, rocks, everything.
I see. So it's like a giant Lego set. But instead of Legos, it's atoms.
Exactly.
And what I find really fascinating is their idea that atoms themselves, they don't actually have qualities like color or taste.
Right. Those are just perceptions, created in our minds.
Well, hold on. So they're saying that a red apple isn't actually red, it just looks red to us?
That's what they thought. Which is pretty mind-blowing when you think about it. And it kind of foreshadows, modern neuroscience in a way.
Yeah, like the idea that our reality is all just a construct of our brains.
Exactly. So, even though these ideas are ancient, they're still incredibly relevant today.
And Democritus, he had this great quote: "It really captures the challenge of trying to understand reality.
Oh, which one is that?
In reality, we know nothing, for truth lies in the depths."
Oh, that's a good one. That's a good one. It really makes you think, doesn't it?
It does. Because if we can't even see these atoms, how can we be sure they even exist?
Yes. That's where things get even more interesting.
And that's what we're going to be exploring next.
Right. Because in the 17th and 18th centuries, philosophers, they really started grappling with this problem.
The problem of how we can have knowledge about the world if our senses might be deceiving us.
Exactly.
And we'll pick up there next time, so stay tuned.
Picking up where we left off, how can we be sure these atoms exist if we can't even see them?
Right. It's like a giant leap of faith, believing in something you can't see or touch.
And philosophers in the 17th and 18th centuries, they really struggled with this.
They were trying to figure out how we can have any knowledge about the world at all if our senses might be deceiving us.
Exactly. And one of the key figures in this debate was John Locke.
Oh yeah, John Locke, big name in philosophy.
Absolutely. And he tried to make a distinction between what he called primary and secondary qualities.
Primary and secondary. Okay, I'm intrigued. What's the difference?
So primary qualities, things like shape, solidity, motion, he thought those belonged to the object itself. They're inherent to the object.
I see. So like a ball is round, whether we're looking at it or not. That's a primary quality.
Exactly. But then you have secondary qualities like color, taste, smell. And Locke argued that these only exist in our perception.
So the ball might look red to me, but maybe it looks blue to you. Or maybe it doesn't have any color at all.
Right. The color is just a product of how our senses interact with the object.
That's pretty wild. So it's like the object has these core qualities, but then our brains add all these extra layers of interpretation.
Exactly. But then along comes George Berkeley.
Another big name in philosophy. Okay, what did Berkeley have to say about all this?
Well, he basically challenged Locke's idea.
Oh, how so?
He's like, can we really conceive of an object, with shape and solidity, but no color or sound?
Yeah, that's tough to picture. I mean, can you imagine a ball that's round and solid, but has no color whatsoever?
Right. And Berkeley argued that this suggests, even those primary qualities, they might only exist in our minds.
So it's like the ball isn't even round unless we're there to perceive it as round.
Exactly. Which, if you take that to its logical conclusion, it really makes you question everything.
Yeah, it's like, what does it even mean for something to exist if it only exists when we're observing it?
Right. And it makes you wonder about those invisible atoms. Like, if we can't perceive them directly, do they even have any real qualities at all?
That's a mind-blowing thought. It's like the
Yeah.
whole foundation of reality is suddenly shaky.
Yeah, and it sets the stage for this incredible journey that science takes over the next few centuries, trying to understand the nature of matter and the universe.
So where do we go from here? I mean, we've got these ancient philosophers debating the nature of reality. How do we get to, modern science?
Well, a lot happens in between, but a key turning point comes with Isaac Newton.
Ah, Newton, the guy who basically invented physics.
Pretty much. And he makes some major breakthroughs in understanding motion and gravity. But even Newton, struggled with this concept of mass.
Well, hold on, you're telling me even Newton couldn't figure out mass? What was so tricky about it?
Well, for one thing, his definition of mass was kind of circular.
Circular, what does that mean?
He defined mass as density multiplied by volume, right? But then density is defined as mass divided by volume.
So it's like you need mass to define density, and you need density to define mass. It gets you nowhere.
Exactly. It's a bit of a definitional loop.
So even a genius like Newton could get stuck in a logic trap. But what about gravity? Didn't he figure that out?
Oh, he definitely made huge strides in understanding gravity. But even there was a puzzle that he couldn't solve.
And what was that?
The puzzle of inertial mass versus gravitational mass? They seem to be the same, but nobody could explain why.
Okay, I'm lost. What's the difference between inertial mass and gravitational mass?
So inertial mass, that's the mass that resists changes in motion. Like the heavier an object is, the harder it is to get it moving.
Okay, that makes sense.
And then gravitational mass is the mass that's responsible for the force of gravity. The more massive an object is, the stronger its gravitational pull.
Right, so basically inertial mass is about resistance to movement, and gravitational mass is about attraction.
Exactly. And the strange thing is, they seem to be exactly the same.
Wait, so something's resistance to movement is exactly proportional to its gravitational pull. Always.
As far as we can tell, yes. And that's a mystery. Newton couldn't explain it. And in a way, we still can't fully explain it today.
Whoa, that's kind of freaky. So we have this fundamental property of the universe, mass, and we don't even fully understand how it works.
It just shows you how deep these mysteries go, and it makes the story of how we've come to understand mass even more fascinating. It's amazing to think about, all this effort to understand mass going back centuries.
Yeah, from those ancient Greek philosophers to Newton, and now we're still grappling with it today.
And it's not just a theoretical problem, it has huge implications for how we understand the universe as a whole.
So we're talking like cosmology now.
Yeah.
The big picture stuff.
Exactly. And this is where things get even more mind-boggling. One of the most startling discoveries in cosmology is that most of the mass and energy in the universe is actually invisible.
Invisible. Okay, you're going to have to explain that one.
So we call it dark matter and dark energy. And together, they make up a staggering 95% of the total mass and energy content of the universe.
95%. So everything we can see, the stars, the planets, galaxies, all that represents just a tiny fraction of what's actually out there.
It's pretty humbling, right?
It is. So how do we even know this dark stuff exists if we can't see it?
Well, we can detect its gravitational effects on visible matter.
So like we see things moving in ways they shouldn't if only the visible matter was there.
Exactly. Galaxies, for instance, they rotate much faster than they should based on the visible matter alone. So there must be some unseen mass holding them together.
So it's like we're seeing the gravitational footprint of this dark matter, even though we can't see the foot itself.
A great analogy. And then there's dark energy, which is even more mysterious. It's causing the expansion of the universe to accelerate.
So not only is the universe expanding, it's expanding faster and faster.
That's what the evidence suggests. It's like there's some invisible force pushing everything apart.
And we have no clue what this dark energy is.
Not really, but here's the key point. Even though we don't know what dark matter and dark energy are made of, we know they have mass.
Because we can see their gravitational effects.
Precisely. So understanding mass is absolutely crucial to unraveling these cosmic puzzles.
So in a way, we're back to those ancient Greeks trying to figure out what stuff is made of.
Yeah.
Except now, it's on a cosmic scale.
It's a pretty amazing thought, isn't it?
It is. So where do we go from here? I mean, are scientists any closer to figuring out what this dark matter and dark energy actually are?
It's still a huge mystery. But physicists are exploring all sorts of radical ideas from supersymmetry to string theory, even extra dimensions.
Wow, it sounds like we're just scratching the surface of what's out there.
Definitely. But that's what makes it so exciting. There's so much more to discover.
So even with all these unanswered questions, why should the average person, someone who's not a physicist, care about any of this? Why does it matter?
Well, I think it comes down to curiosity. Humans are naturally curious beings. We want to understand the world around us, our place in the cosmos.
And the more we learn, the more we realize how much we still don't know.
Exactly. It's a never-ending journey of exploration and discovery.
And even if we don't find all the answers, the pursuit of knowledge is a reward in itself.
I completely agree. And if you're interested in exploring these ideas further, I highly recommend Jim Baggott's book, Mass. He really takes you on a fascinating journey through the history of our understanding of this fundamental concept.
Yeah, it's a great read for anyone who's ever wondered about the nature of, well, reality itself. And if this deep dive has sparked your own curiosity about mass, the universe, and all the mysteries in between, we'd love to hear your thoughts. Join the conversation on our website or social media. Until next time, keep exploring those ideas that matter.